Okay, here we go. So key terms for dealing with algebraic expressions today. You need to be really good at manipulating things algebraically. Skills here today are basic skills, but these are stuff you use all the time. These are the same skills my calculus kids do. I tell them at the beginning of the year, by the end of the year, they're going to be really, really good at algebra. Because if they solve a problem, it may be 10, 15 steps to solve the problem, but only the first one or two are actually calculus. The rest of it's algebra, combining terms, evaluating, that kind of stuff. So you have to do a lot. These are skills that later on in other classes and other things you do are going to be important. So to evaluate, substitute numbers in for letters, and then simplify the expression. This is actually something you do in a lot of other classes. Think about your science classes, and you're doing math in there. Usually, what is it? You have your formula. You plug the numbers into the formula, and you simplify. It's evaluating. Do an awful lot of that. Okay. A term is a number, a variable, or a product of numbers and variables. Okay. A single item within an algebraic expression is a term. A variable by itself, a number by itself is a term, or a combination of them in one place multiplied is a term. Coefficient is the numerical part of a term. So if you have variables and numbers, the coefficient is the numerical part. So like 2x, 2 is my coefficient. Constant term is no variable. There's no variable involved. It's constant because it doesn't change. It doesn't vary. That's no variable, no varying. Like terms. The like terms are where the variables are exactly the same. Same letters and same powers. So it has to not just be the same variable, but it has to be the same power on those variables to be like terms. To combine like terms, they have to be like terms to be able to add or subtract them and combine them up. Any questions on this? Come on. There we go. All right. So, sum, difference, product, quotients. What does it mean when I have the sum? Yeah, you're adding. Sum is addition. Put that down. Put down addition. Okay. Difference is what? Subtraction. Product means multiplication. Quotient means division. Here's what I want you to spend the next couple of minutes doing. Come up with as many alternatives for addition as you can come up with. Any other words that mean addition? Any other words that mean the same thing as, or words or phrases that mean the same as subtraction? Any other words or phrases that means the same as multiplication? And the same thing for division. Come up with as many possible things as you can think of. Work with others as you're doing that. Okay? So spend a couple of minutes. Okay. So there could be a myriad of possibilities for your answers. So for like sum, you have addition, more than, increased by, things like that. That means that you're going to be doing addition, right? Okay. Difference, less than, decreased by. Multiplication times twice. Twice is specifically multiplying by 2. Triple something, multiplying by 3. Okay, does that make sense? These are words and phrases, because one of the hardest things to do often, particularly with word problems and stuff, is converting words and phrases into algebraic expressions and understanding what they're asking. That's kind of what this one's about, to get your mind thinking in that direction. Okay? Now, example number 1. Evaluate each expression. Okay? So, 7 times a plus 4 plus 3b minus 8, evaluated if a equals -4 and b equals 5. First step, plug in the numbers. Any time I have something I'm evaluating, a formula I'm using, first step, just plug in the numbers. No simplification until you plug the numbers in. Remember the quadratic formula. It's nasty. Every time I do the quadratic formula, and we will go over it again in here, I just plug the numbers in. I don't take the minus b, and if b is -2, I don't, oh, minus b, that means that's +2. So I don't put right down, I put minus -2. I write down what it is in there. I do not change anything on my first step. So your first step, just plug the numbers in. Second step, start to simplify. Now, you can simplify more things in more than one step if you wanted. All I did here was I took 4, -4, and added them together. What do you get? 0. 3 times 5 is 15. Okay. I try not to do too much at once. Now, I could probably do all of this going from here to the final answer in my head without too much of a difficulty, but I don't like to do that because I don't want to make a mistake. If this was a test and I'm making the answer key, I'm showing every step that would need to be shown. Here's what's going to go on in here. You don't have to show every single solitary step unless I tell you otherwise. But it's a good idea to show your steps, show all your work. Okay? So I can see what's going on so you don't lose track of what's going on. Does that make sense? Okay. And then the last one, your final answer. Add them together. What's 7 times 0 is 0. So you get 15 minus 8. 7. Okay. So the next one's a little trickier because I've got a lot more stuff going on. But your first step is still exactly the same thing. Plug the numbers in. That's all you do is plug in the numbers. You'll notice when I put in -3 for y, I put parentheses around the -3 because I'm doing something with that -3 other than just putting it in there. Okay, does that make sense? First step, just write the numbers in. Okay. And then start simplifying it. Notice I didn't do too much. I squared the 6, and I squared the -3. That's all I did. I didn't yet combine them up. I just did my squaring, following order of operations. Work on what's inside the parentheses. Okay. And then the next one, 36 minus 9 is 25. 2 times 25 over 3. And I got the wrong answer. What is my answer supposed to be? I just realized I did that wrong. 50 over 3. $54. Where do you get 54?
So 36 minus 9 is 27. 27 times 2 is 50.
It is 27, not 25. I screwed up twice. Thank you very much. Thank you. Thank you. I screwed up twice. My bad. So I get 2 times 27 over 3, which means that I get 54 over 3. That's your answer. Can you reduce 54 over 3? Yes, you can, which it is 18. Boy, man, I really blew this one. See, that's what I get for trying to do stuff at the last minute. See, this is what happens when you try to do stuff at the last minute, because I was doing this last period on my prep, trying to set it up.
May 17th.
Yeah, that's when they got printed. That's when your copies got printed. I did this part, this stuff with the boxes this morning, so I wouldn't have to write with my thumb shoulder. So normally I like to do it, work it out, so you see me work the steps. I don't like to do the boxes because you don't see the steps being worked like you work, but I don't want to try to reach up any higher than about this. Okay? And if I write with my left hand, it's even worse. You won't even be able to read anything. Okay? So, questions? And good pointing out that I screwed up even though it's being recorded, so now everybody's going to know that I screwed up. Okay. Your turn. Do these two. Okay, so let's do this. So once again, your first step is to plug them in. I have -2 times n minus 3 times 5n minus 6. M is -4. N is -2. And I think I did this backwards. Did I do that one backwards? I did do that one backwards. My bad. There's your first step. My bad. I put them in the wrong order. So your first step, just plug the numbers in. Second step, start to simplify. 4 minus 3 is negative 7. I went ahead and multiplied the 5 and negative 2, and I got negative 15. Oh, my word. God. Just trying to see if you're paying attention. Yeah. You believe that? Okay. I got the rest right. 4 minus 3 is 7. Okay. So that is not, so that is 2 times 7 is not 28. 2 times, oh my Lord. I am going to fix this. Which means my final answer is wrong, which it should be what? Yeah, negative 2. Oh my God. I'm so embarrassed. Yeah, so what? Who cares? It's not like it's a test. But it's also good to see it is okay to make mistakes as long as you fix your mistakes and you catch your mistakes. Okay? It's not that big a deal. It's not the end of the world. Okay. Might seem that way. Okay, next one. First step, plug in the numbers, negative 2, positive 3. Ooh, I did that one right. I plugged the numbers in correctly. Okay. Negative 2 cubed is negative 8. And then I have minus 2 times 9. 3 squared is 9. So far, so good. Negative 8, minus 2 times 9, so it's negative 8 minus 18, all over 2. Negative 26, all over 2. Negative 13. I didn't screw that one up. Questions? Hey. Simplifying by combining like terms. Okay. Let's actually do this one over here first. Okay. Your like terms are where the variable and the exponents are exactly the same. So for example, I have h squared. Do I have any other h squared? No. So I have 6h and minus h. Those two are like terms. This is a like term. That's a like term. So I can combine those up. Okay. And then I go to the next one. I have 7j. And then I have j. Those are like terms. The variable's exactly the same. Then I have negative 8j squared. There are no other j squared, so there's nothing to combine that with. So I get 9h squared. That doesn't change. Minus 7h, because it's negative, minus 6h minus 1h. And then plus 8j minus 8j squared. This is standard form. Variables in alphabetical order from highest power to lowest power. So h comes first, so it's h squared. And then h, my powers work down on that. If I have more than one variable, the second variable, the powers go up as I go towards the end. This is standard form. I will always do things, or try to always do things in standard form whenever I can. If you had that rearranged, I wouldn't really care all that much, but that's how it should look. Okay? And then go back to this one over here. Before I can actually combine up like terms, first thing I need to do is distribute. Distribute the negative, distribute the 2. Okay, that's my first step. So negative 3k minus m, 2 times k, 2 times negative 4m. And then I combine up my like terms. I have k's, I have m's, I have a negative 3, positive 2, negative 1k, negative 1m, negative 8m, negative 9m. Okay, does that make sense? First you want to distribute, then combine up like terms. Okay? Easy peasy. Your turn. Okay. Let's look at these. First example, you only have one set of like terms. The only like terms you have are negative 7y and negative y. None of the rest of those terms in there have any other corresponding like terms. So the 4x squared stays the same, the 5x stays the same. You have negative 8y plus y squared. Like I said, I put it in standard form. If the order you have is different order, but all the terms are the same, particularly the negatives and positives, are also correct, I'd be okay with that, but I want to try to get as much standard form as possible. This one, the first thing you need to do is distribute the negative, distribute the 2. And I screwed that up again for some reason today. I think 2, for some reason, I've got it stuck in my head that 2 times 5 is 15. Is 2 times 5 15? Yes? Who said yes? Okay, you're kissing up. So this should be negative 10b. I think I get everything else right on that, correct? Yeah. And so when I get down to here, raise this stupid mark. So that's not negative 4b. What should that be? Or sorry, the negative 4a is correct, and this should be negative 13b. My bad. Any questions on this? Okay. So these ones here, you're writing each phrase as an algebraic expression. These are not sentences. They're phrases, right? Because they don't have verbs and stuff like that, right? They're just phrases. The sum of a number and 3. Now, you can use any variable you want. I use the same variable for all of these. Sum means what? Addition. So this is n plus 3. That's what I have. Could you have 3 plus n? Is that a possibility, 3 plus n? Yeah, because addition is commutative. Order doesn't matter. However, standard form, variable first, number second, as long as the order doesn't matter. Because if you have certain ones where the phrase is, depending on the phrase, you have to actually have the variable in the back. But if it's addition, it doesn't matter. Okay, subtraction, it does matter. Second one, difference of 5 in a number. Order matters. It must be 5 minus your variable. Like I said, I use n for all of my variables. So it's 5 minus n. Why is it 5 minus n instead of n minus 5? Difference in subtraction. Order matters in subtraction. It's the first one minus the second one. Difference of these two objects. So it's the difference of the first object minus the second object. And because the 5 comes before the number, it has to be 5 minus n, not n minus 5. Okay, product, order doesn't matter. Multiplying, you just slap them together. 6n. Quotient of 4 in a number, so division order does matter. So it's 4 divided by n. You can write it like this, but more accurately for what we would be doing in here, you would write it as 4 over n as a fraction. And order does matter with division. Questions on this page? These were a little trickier. 8 more than a number. So when I have 8 more than, so if you have $10 and I have 8 more than you do, how much do I have? Really, it's money. You should be able to get money. Money kids always get money. If you have $10 and I have 8 more, how much do I have? 18, because you added them. It's 8 more than. So I have the number plus 8. If I have $10 and you have 3 less than I do, how much do you have? I don't like your money style. I'll work with you. I'll get rich off of you. 2, he says it's 2. 10 minus 3, or sorry, 10 minus 3 is not 2. Okay. Well, we'll do that. That's fine. So it would be subtraction. And what did you do? You took the number, you took what I had, and subtracted 3 from it. Even though 3 comes first in my phrase, this phrase is different than the other one. So it's 3 less than that. I take my number and I subtract 3 from that number. It is n minus 3. Read the phrase carefully. This is a tricky one because of that. Okay. The next one, the quotient of the sum of 2 and a number and 3. This is a tricky one. I have the quotient, which means I'm dividing. The quotient of this and this. Those are the two things that I am dividing. You have to read the phrase carefully. It's not the quotient of 2 and a number and then 3. It's the quotient of the sum of 2 and of the number and 3. And I did that one wrong too. Oh my God. I will go back and fix some of these. But my video will not be fixed because I'm just recording it once. I'm not going to record it again tomorrow. Okay. The sum of 5 times the number and 4. So the sum means I'm adding. The two things that I'm adding are 5 times the number and 4. Those are the two things that are being added. So you must read the phrase carefully. So I get 5n plus 4. Questions? Okay, your turn. Do those. Okay, so the sum of 7 in the number, I'm adding 7 in the number. N plus 7. 11 more than the number, so I'm taking a number and I'm adding 11 to it. The difference of twice a number and 8, so I'm taking the subtraction of twice a number and 8. 2n minus 8. 5 less than a number minus 5. Questions? Easy peasy. Start out easy. Makes everybody happy. Yep, that's it.